Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Sunil Kumar Bandaru, place educator in Academy. Students, from this video onwards, we are going to discuss measurements through topic-wise MCQs. This series will be very useful for all your competitive examinations, all JE examinations and also AE examinations. Okay, let us start the session. And students, please try to share the information to all your friends. Coming to the first question. The errors due to human negligence is dash. The errors due to human negligence is dash. First of all, let us take the types of error. The types of error, mainly three types. Types of errors. These are mainly three types, guys. What are those? First one, gross error. Okay. And the second one, systematic error. Third one, random error. Random error. Okay. So gross errors are nothing but the errors due to human negligence. Due to human negligence. We know very well some persons are neglect while taking the readings or while calculating like that. So if we are getting any errors by human mistakes due to human negligence, that is human mistakes while reading, recording or calculating. In any case, if you are doing as mistakes, then those errors are coming under gross error. And coming to the systematic errors are nothing but again three types. One is environmental error. One is instrumental error. Very important question. Instrumental error under systematic errors. Okay. And observational error. Observational errors are nothing but parallax error. That is the error due to our human eye. Our human eye may not detect perfect value. It having some tolerance. Okay, so that means this parallax error are common for all. These errors are common for all, but this gross error not common for all. Some persons only doing the mistakes, some persons only negligence. But if you concentrate on the reading also, you are getting some error that is nothing but parallax error, that is common to all the persons. Why? Because our human eye may not detect exact value. Okay, so those errors are coming under observational error. Environmental errors are nothing but you can say due to temperature, pressure, electromagnetic fields. Those errors are nothing but you can say environmental error. Instrumental errors are nothing but you can say due to aging effect. Wrong instrument you are using. Okay, and also loading effect, very important. Loading errors are comes under instrumental error. Random errors are nothing but we don't know the exact reason. Okay, don't know exact reason. So unknown errors. Exact reason. So unknown errors, you can say unknown errors. Okay, so we can't minimize these unknown errors now. So why? Because we don't know the reason. So for that purpose, what we are going to take, we are going to calculate the standard deviation of errors. And after that, we have to take the probable error. The most probable error, that is plus or minus 0.6745 of the sigma. Okay, 6745 of the sigma. That means we have to multiply with the 67% of the standard deviation. Then we are getting the random errors. Okay, I think all of you get the idea about the types of errors. Okay, once again, errors are mainly three types. Okay, gross error, systematic error, random error. So gross errors are nothing but due to human negligence. Systematic errors are nothing but environmental, that is nothing but temperature, pressure, any electromagnetic fields like that. And instrumental errors are nothing but due to any aging effect, wrong instrument. That means for if you want to measure just 5 amps, you are going to use 0 to 500 amps meter, that is the wrong meter. Okay, so like that, wrong selection of the meter. Loading effect Loading effect, when we will get, whenever you are using low sensitivity meters, then loading effect will be more. Okay, loading effect will be more. And observational errors, these are nothing but parallax error that is common to all the persons. Random errors, we don't know the exact reason, and we can eliminate that one, or we can get the idea of that one by finding the standard deviation and 0.6745% of that. Okay, coming to the next one. So human negligence, that is gross error. Coming to the next question, if sigma is standard deviation, the limiting error is dash. Just now I have given limiting error is nothing but, we can say, probable error. Nothing but, can say, probable error. That is plus or minus 0.6745 of the sigma. Okay, so the answer is option D. Very important question. It is already asked in previous SSC J examination. Okay, coming to the next one. So the difference between measured value and the true value of the quantity is dash. Very important question and very easy one. Measured value to true value. So that is measured value if you can consider AM, and true value if you can consider AT. AM minus AT, that is nothing we can say absolute error. Absolute error. And one more important point, it is nothing but, can say, static error, guys. Static error or absolute error is nothing but AM minus AT. Okay, AM minus AT, very important one. And relative error means if it will be with respect to AT, then that will be a relative error. Okay, so the answer is option B, absolute error. Coming to the next question. A meter reads 100 volt and the true value of the voltage is 99 volt. Find the static error. Find the static error. Just now I have given the, come on, do the answer. Static error. So students, here how you have to watch the video is, whenever I have given the question, if you are watching this one as recording, whenever I have given the question, that is as question is appears, you have to pass that one and try to give the answer yourself, and after that check with my answer. Okay, so in that way you have to practice this one. Static error, just now I have given the AM minus AT. AM minus AT. So what is the AM? AM, meter reads 100 volts and true value is 99. Meter 100 volts, true value is 99. So that means 1 volt plus 1 volt. So the answer is option A. Plus 1 volt. So the answer is option. Okay. So if they are asking same way relative error, then that formula is belongs to true value. AM minus AT by true value. Okay. So if they are asking guaranteed accuracy error, this is nothing but with respect to error with respect to full scale value. Full scale value. If they are asking limiting error, that is always error with respect to true value. With respect to true value. Okay. So if they are asking limiting error is nothing but full scale value by true value into guaranteed accuracy error. So if they have given guaranteed accuracy error, we have to take full scale value by true value into guaranteed accuracy error. Okay, so note down. Very, very important points, guys. Okay, in most of the examinations, these will be repeated. Coming to the next question. Here they have given R1 plus R2. Here plus or minus 4 ohms means it is nothing but like a tolerance or error. Okay, so here they are asking R1 plus R2. We can easily add the magnitudes 100 plus 50, 150. But here in all the options they have given 150. And about the errors given. So how to add the errors? So for that, note down, very important point. In case of addition, note down guys. In case of addition or subtraction, absolute errors are added. Absolute errors. Absolute errors in the sense errors in values. Errors in values. Okay. Errors in values. Not in percentages. Values. Not in percentages. If they have given errors are in percentages, we have to convert it into values and then only we have to add. Okay. In case of addition or subtraction, absolute errors are added. Okay. If errors are in percentages, just convert into values and add them. Okay, this is a very important in case of both addition and subtraction. Multiplication division, another one. In that multiplication division, percentage errors will be added. Okay, so here for this question, R1 plus R2. So 100 plus 50, 150. Here errors they have given in values only, so we can directly add 4 plus 2. That is equal to 150 plus or minus 60. So the answer is option. Coming to the next question, guys. If they have given subtraction case also same. Errors will be added only. So R1 minus R2, 100 minus 50. But don't subtract errors. Errors are always add only. Okay, and they have given in the absolute values, not in percentages given. 50 plus or minus 60. Okay, 50 plus or minus 6. Coming to the next question. Here multiplication. Note down for multiplication and division. Yes. In case of multiplication and division, percentage errors are added. Okay, that is not in values. If errors are in values, convert into percentages and add them. Okay, so here multiplication they have given, and the errors are also in percentage values only, so no need to worry. Percentage errors are added. 50 into 10 plus or minus, percentage errors are added. 6% plus 3, that is equal to 500 plus or minus 9%. So the answer is option. Okay, that is first question in this session. Okay, so the limiting errors of measurement of power consumed by and the current passing through the resistance are plus or minus 1.5% and plus or minus 1% respectively. The limiting errors of measurement of resistance will be dash. What I said previously in the previous session, you have to pause the video. Okay, try yourself. After that, check with my answer. Okay. So in the previous session, what I have given, in case of multiplication and division, percentage errors are added. I have given this point now. Yes. Here, measurement of resistance. They have given for the measurement of power consumed by, and for the power and for the current. What will be the errors? Plus or minus 1.5% and plus or minus 1%. That means for power measurement, the errors are plus or minus 1.5. For current measurements, the error will be plus or minus 1%. Now we have to find out the resistance. Resistance R is equal to, in terms of power and current. So power is equal to I square into R na. So if you want R is equal to power by I square. So here if you want error in the resistance measurement, power measurement by current square. Power measurement plus or minus 1.5% is the error. Current measurement I into I plus or minus 1% error into 1% error. In case of multiplication, errors will be added. So plus or minus 1.5% by plus or minus 2%. In case of division also, percentage errors will be added. 1.5 plus 2, 3.5%. So what is the answer, guys? 3.5. So the answer is option C. Okay. So the answer is option C. All of you clear? So in case of multiplication or division, the percentage errors will be added. Okay. Coming to the next question. A 150 volt moving iron voltmeter reads 75 volt when used in a circuit under standard conditions. The maximum possible percentage error in the reading is dash. The maximum possible percentage error. Just in the previous session, I have given percentage error or relative error. Relative error. This is nothing but AM minus AT by AT. Okay. So here 150 volt moving iron meter reads 75 volts when used in a circuit. Okay. When used in the circuit under standard condition. The maximum possible percentage error in the reading is dash. In the reading is dash. AM minus AT by AT. So 150 volt moving iron voltmeter, that is the rating of the voltmeter, and it reads 75 volt. Okay, so whenever it is going to be measured, the measured value you are getting 75. Okay, and the true value, that capacity is nothing but 150 by true value 150. That is nothing but minus 75 by 150. That is 1 by 2 minus 0.5. But they have not given minus, means we have to go for that one only, but 0.5 only. Okay, measured value minus true value. So what we have measured, whenever it reads this value, means it measured this value. Okay, coming to the next one. A 0 to 200 volt voltmeter has guaranteed accuracy error of 1% of full scale reading. I have already given now. Guaranteed accuracy error is always with respect to full scale value. With respect to full scale value. And limiting error is with respect to true value. Okay, so here 1% of full scale reading. So what will be the guaranteed accuracy error, guys? 1% of full scale reading is nothing but 200 volt. That means you are getting 2 volt. So if you are going to measure 10 volt, you are getting 2 volt is error. Okay, 20 volt you are getting the 2 volt is error. 50 volt you are getting the 2 volt is error. 100 volt you are getting the 2 volt is error. So it is the maximum error of if you are going for measure the full scale value. Okay, so if you are going to measure the 50 volt, then also this error is common. 2 volt error you are getting. So that means 2 volt error is how much percentage of the 50? 2 volt error is how much percentage of the 50? 2 volt error is how much percentage of 50? That is nothing but 4% now. So that is the limiting error. That is the limiting error. So this is as per the understanding, guys. This is as per the understanding. How much percentage means how you can get how much percentage of the 50? 50 into how much percentage? X percentage is nothing but that 2 volt error. So we have to calculate like this. X percentage 51, 52, that is equal to 4%. 4%. So 2 volt is the 4% of 50. Okay. So this is as per the understanding. Okay, so guaranteed accuracy error 1% means it is with respect to full scale value. 2 volt is the error. This is a grand sure error. If you are going to 50 volts, then also you will get the 2 volt error only. But 2 volt is how much percentage of the 50? 4%. But so to avoid the confusion of this conventional method, we have the formula. What is that formula? limiting error is equal to full scale value by true value into guaranteed accuracy error. This is a simple formula. Full scale value means maximum value. So higher value, so 200, and true value is nothing but which we are going to measure, that is 50 into guaranteed accuracy error 1%. So 50 by 4%. So like that you can do. This is a shortcut. Okay, so very easy. No need to write the formula also. Okay, just high value by low value into error. High value 200, low value 50. So 200 by 50, 4 into 1%, 4%. Like that you can give the answer very easily. So let us check one more question with the shortcut, then you will get understand easily. A 0 to 100 volt voltmeter has a guaranteed accuracy error of 1% of full scale reading. The voltage measured by instrument is 5 volts. The limiting error is dash. What is the limiting error I have given? Full scale value by true value into guaranteed accuracy error. Full scale value is nothing but 100 volt. True value is nothing but 5. Guaranteed accuracy error 1%. That is 20%. So the answer is option D. That is 20%. So the answer is option D. Okay. Students, you can also get the PDF of this topic-wise MCQs in measurement. Not only measurement, in any subject belongs to JEE or A examination. You can just search with the SuneelEngineeringAcademy.com. Okay, so in this you can select SSC JEE or State A examination PDF, and you can click on electrical engineering PDF. You can find out individual and also electrical 6 subjects PDF you can download. Okay, if you open any of this one, you can get the details how you have to download and all those. Okay, so you can go like this, and you can also get. Coming to the next question, I already said you are watching this one as recording now, so you have to stop the video and you have to solve the question, and after that you have to check with my answer. Okay, here there is no percentage. So they have given 0 to 300 volt has voltmeter has an error of plus or minus 2% of full scale reading. What is the range of its readings if the true value is 30 volts? So whatever the error they have given, that is belongs to full scale reading. So which error is belongs to full scale reading? In the previous session I have given guaranteed accuracy error always with respect to full scale reading, full scale value, and limiting error is always with respect to true value. Okay, so here if you are going to measure full scale value, that is 300 volts, you are getting plus or minus 2% is the error. So 2% means 2% of 300, that is 300 into 2% means 6 volt. So if you are going to measure maximum value, it is the error is 6 volt. So this is nothing but guaranteed accuracy error. So this error is guaranteed we will get. So that means if you are going for 300, you are getting 6 volt is the error. 200 volt also you are getting the same 6 volt is error. If you are going to measure 100 volts also, this error will be comes. If you are going to measure 30 volts also, this error will be common. 6 volt error is the common. Okay, so this absolute error is the common. Okay, but the 6 volt will be how much percentage is the limiting error? How much percentage? Here just 2% means here for 200 case it may be very high percentage. For 100 it may be 18%. So like that. So the percentage may be increases, but values are same. Okay. So if you are going to measure 30 volts, then also the error is nothing but 6 volt error is the common. Okay. So plus or minus 6 volt. So minus 6 means 24, plus 6 means 36. So it is the reading. It is the reading. So guaranteed accuracy error, as name itself, it is guaranteed we are getting this error. If you are going for 300 volt, that is a 6 volt. If you are going to measure less also, the 6 volt error is the common. Okay, the readings will be 24 to 36 volt. Coming to the next one. A 0 to 250 volt voltmeter has a guaranteed accuracy error of plus or minus 2% of full scale reading. The voltage measured by voltmeter is 150 volt. The limiting error is dash. Come on students, try to find out, and after that check with my answer. Okay, so I have given the simple formula to find out the limiting error. Now what is that? full scale value or high value by low value or nothing but true value into guaranteed accuracy error. Okay, very easy questions. Full scale value 250, true value 150 into error is nothing but plus or minus 2. 53 is 50 points. 5 into 10% by 10 by 3. 10 by 3 means 3.33%. So the answer is option D now. So the answer is option D. Okay, coming to the next question, guys. Next question, this is belongs to definitions, terminology. So what is the sensitivity, guys? Sensitivity is nothing but ratio of response to the input signal. That is nothing but change in output by change in input. Generally, change in output by change in input. So change in output by change in input in the sense here, that is nothing but you can say ratio of response to the change in input signal. Response is nothing but output. Ratio of output by change in input. Resolution. Resolution is nothing but smallest change in input to which the instrument can be respond. Accuracy is closeness to the true value. Precision, measure of reproducibility or repeatability. Okay, so then A3, B4. A3, B4, we have two options. After that, C1. So the answer is option E. So the answer is option E. Okay, coming to the next question. The degree to which an instrument indicates the changes in measured variable without any dynamic error. Without any dynamic error. So we know very well about the repeatability, precision, and hysteresis. All these are not means the answer is nothing but fidelity only. So this fidelity is nothing but the degree to which an instrument indicates the changes in measured variable without any dynamic error. That is nothing but you can say fidelity. And coming to the next one, what is the dead time of an instrument refers to? Dead time. Okay, for example, if it has to be take some times to respond. So what is the corresponding time? This is nothing but you can say dead time. Okay, so here it is nothing but it is the time. Okay, so in options which is belongs to time, so it is the time encountered when the instrument has to wait for some reactions to take place. Okay, so the answer is option B. Coming to the next one. Perfect reproducibility means the instrument has tests. What is this perfect reproducibility? If you are getting same values for every time, then you can say that is the meter is producing stability. The instrument is high precision, highly precision. Okay, highly precision. So highly precision means there is no drift, there is no variation. Drift is nothing but movement. Okay, so there is whenever there is no variation means same values you are getting. For example, 5 amps is the true value. If you are getting AM value, that is measured value 4.95, 4.95, 4.95, 4.95, like this, that is where there is same values repeatedly. You can say highly precise, there is no drift. There is no drift in the measurement. It may be near to the true value or may not be near to the true value. If it is 4, then also it is a highly precise. Okay, and no drift. So the answer is option D. So the torque by weight ratio of an instrument indicates that here torque by weight ratio always indicates sensitivity. Okay, if the torque by weight ratio is more, the sensitivity is also okay. So that means whenever there is a small change in the input, the output is changes means it will get the torque. It will get the torque means the reading will be changes. Okay, so as the torque by weight ratio is more means sensitivity is more. Sensitivity is more. Okay, as sensitivity is more, loading effect also less. Is also very important. Loading effect. A is less, that is inversely proportional. So the answer is option. Okay. Okay, students, we will discuss the remaining questions in the next session. Okay. And if you have not subscribed this channel, please click on subscribe button, and also please share this sessions to all your friends and encourage me. Then only I can bring you a lot of sessions. Okay. If you are not